Hey guys, it's Miss Robertson, and we have a test on Wednesday. So I'm going to do number 1 and number 2 on the review with you, and maybe it'll help you. Anyway, I'm not going to do number 3. You're on your own for that one. Okay, when we are working with rational functions, step 1 is always factor everything. So let's go ahead and look at our numerator. 3 and 9 are both divisible by 3, so we can factor a 3 out, and we're left with x minus 3. On the denominator, quick factoring, two things that multiply together to get x squared are x and x. Two things that multiply together to get 6 and subtract to get -1 are 2 and 3. This tells me my signs are different. This tells me what goes in front of the biggest number. So -3 and +2. Okay, step 1, factor everything, check. Step 2, let's look at domain. Always look at domain next. Domain comes from your denominator. So our domain, we're going to set both factors or all factors in your denominator not equal to 0. So x plus 2 does not equal 0. And x minus 3 does not equal 0. So our domain is x cannot equal -2 and x cannot equal +3. If your teacher does not tell you it has to be in interval notation, then it doesn't have to. So we could write x does not equal -2 and x does not equal +3 over here. Or you can write interval notation, whatever you choose. All right. So once you're done with domain, then see if anything cancels out. Well, look at here. X minus 3 cancels out. And if a factor cancels out, you create a whole. So we will have a whole when x minus 3 equals 0 or at x equals +3. So x equals +3. Next, we're going to look at vertical asymptotes. Vertical asymptotes come from the denominator again, and what is left, so this vertical asymptotes, what is left, the x plus 2 equals 0, that creates our vertical asymptote, so x equals -2. Next, let's talk about horizontal asymptote. Horizontal asymptotes have to do with degree. So the degree of our numerator is 1. If there's nothing there, it's really a 1. The degree of our denominator is 2. So we have bigger degree on bottom. So our horizontal asymptote is always y equals 0. If you have a horizontal, you will not have a slant asymptote. You can also call these oblique asymptotes, oblique. Those are the same things. So if you have a horizontal, you will not have a slant. The only time we have a slant is if the degree of the top is exactly 1 higher than the degree on the bottom. And so we have none. X-intercepts, these come from the numerator. And you're going to set those factors equal to 0. So what factors do we have in our numerator? Well, just 3. So 3 does not equal 0, so we have no x-intercepts, so none. Which makes sense because we have a horizontal asymptote at y equals 0. When you're finding your x-intercepts, you only want to set the factors that you still have left in your numerator. Notice we have this x minus 3, but it canceled out, so it's not available for our x-intercept. Y-intercept. Now, y-intercept is really cool because remember a y-intercept is when you have a number for y and 0 for x. So basically, you're plugging in 0 in for x and solving. But in rationals, if I plug a 0 in here, 0 times anything, that cancels out. If I plug a 0 in here and here, then those cancel out. So what I'm left with is just -9 over -6. So that is my y-intercept. Remember, if you forget this, just plug the dang thing in your calculator and check your table. But Negative 9 over negative 6. Reduces, 3 goes into 9 3 times. 3 goes into 6 2 times. Negative divided by negative is a positive. So your y-intercept is 0, 3 halves. Okay, that's number 1. Let's look at number 2 real quick. Oh, let's stop at number 1. We're going to make a break in the video.